All right. Hi everyone. So it's roughly the same crowd as we had before in graphics, right? Plus a few more people. Do you actually hear me without this equipment, or do we need it? Okay, can work without it. So, right. Sorry?
Stream might need it.
It's not streaming yet. Should be.
Yeah, but maybe I need a microphone.
Ah, it's via camera. I don't have the fancy camera, the microphone that Mario had around. So I just use it the live cam as usual. So, but that should be fine anyway. As long as the slides are visible, the sound should be somewhat comprehensible. So we're switching back from C++ to a more comfortable Java world, is it, or the other way around? No? Okay. So one of the insights that I had just from just to give some context, we had in the graphics class, graphics programming, we just had an invited talk by a master student who is fairly involved and has a fairly deep background in C++. And it was really insightful to see how many of the features actually are increasingly aligned. So all the new C++ 14 and 17 features, most of them you'll find in some way or another way in Java as well. Major exceptions being the auto typing, which is not available in Java as of now. But the idea of what's referred to as templates in C++ would be probably generics in Java. And you'll see those more over the course here. So there's a bit of an arbitrage effect, meaning you have a benefit from having seen that talk, especially for those of you who actually come from C++ background. For the ones that have Java background, you probably don't have any, yeah. Well, it probably won't make any much of a difference there because you had those insights. Cool. So today we're talking about state and persistence in Android. Mario still wanted to talk about the layout in particular and the hierarchy of views and so on, but I felt I'll leave that to him, so it's a more coherent presentation that he can deliver whenever he's available to do so. Because for the most part, I think you guys are comfortable with the GUI as far as I've seen in the labs, but it's time for us to get a bit under the bonnet and actually think about, you know, how to deal with data persistently, right? And so that's something we're trying to cover today as part of this lecture. I wanted to do a bit more live coding than I thought, but I kind of gave up on that idea because I realized that it probably would affect the stream badly, given that my machine is not too powerful right now. I still need to look for a solution that would accommodate that a bit better. Hello, I see joining. Okay. So persistence. Or do you want to talk about hierarchy of view organization?
No, then next hour.
Yeah, that's what I next time, right?
Next time, or if you don't fill up the time, I can finish.
I need a lot of time.
Okay.
So just leave it for perhaps next Thursday or something.
Yeah.
We can do an intro lab on that. Cool. All right. So persistence it is. So you guys have dealt with persistence already in Android, didn't we? Or no? Yes, no?
Don't think so. What's been persistent?
Yeah, I'm just asking.
Don't think so.
Oh, we didn't, right? So some of you probably have experience with Android before, right? So because most of the time when I talk to people, they have mucked around a bit, and obviously you come to that stage, how do I actually save data? Static charge. And in Android, there's actually an abundance of it. Has anyone any background on how to do persistence in Android, or what are the types, including guessing? What are the available facilities? Yep.
Shared preferences.
Shared preferences, yeah, we dealt with those ones, yep. So that's a form of persistence. Yep. Anything else? Cool. Right. What do you think is intuitively desirable for what kind of persistence modes do you need to have? How do you want to keep state or data on a mobile application? What are the features you want to see there? I think it's good to ask this question before we look at what's available, because it gives you I think it's usually a good pointer towards what you expect from a system, but also what may be a good future development if we don't cover all those aspects in with the existing facility. So what kind of data do we need to deal with on a mobile device? Yep.
Login credentials.
Yeah, cool. Yeah, those would be ones. Yeah. Let's think more on your application perspective right now. I mean, yeah, sure, there can be logins as well, but let's leave the OS stuff bit aside. Let's assume that it's all managed. But for your application purposes, you want to write an application, and you know, obviously persist data to some extent. You know, maybe I don't know. Perhaps you do social networking, but assuming you want to keep it on your local device to some extent, what is the kind of features you're looking for there? Rather, what are the features? Yep.
I mean, are you talking about saving local, like specifically saving local files on your device?
Yep.
Or are you talking about, I don't remember what the system was called, but in the whole talk about all the different modules, one of them was the blank that was generic that you could set up to like be connected to any sort of persistence data storage.
Yeah, cool. Yeah, we're getting some. Yeah, cool. So let's think about data. What kind of data do we deal with on mobile phones?
Images,
Images.
scores.
Exactly. So we have more structured data and possibly more unstructured data if you want. Like let's count images as rather unstructured. That there's a matter of argument in the end. But high scores, for example, would be probably highly structured, right? So so we're probably then generally dealing with some sort of media. We're dealing with structured data, like you know, tabular data typically, and yeah. Apart from that, files, right? I mean, you guys probably transfer files from and to your phone. I don't know how you use it, but I tend to, you know, use a large number of different file viewers to actually inspect files that are sitting on my phone. So there's quite a broad set of different needs for persistence. So shared preferences is not the only thing, only way to do it. So, but it was the one that you should have dealt with already to some extent as part of the labs. Because that's one of your way of handling things around. The other thing, the other feature is to use basically the internal file system, right? So you can use the phone's internal storage, no surprises there. So it's pretty like your regular machine. Then in addition, we have external storage. What's external storage for phones?
SD cards.
Yep, cool. Removable devices. Yeah, then the SQLite database. So originally when you mentioned there was something in the modules section of the Android framework that we talked about, I thought you would be mentioning SQLite. So basically you have a fully fledged built-in SQL database at your avail for any application, right? So you can instantiate it based on your needs and then use it for things like high score, for example, right? Advantage is structured, disadvantage is structured, so you kind of need to invest quite a bit of time in actually getting going with this one. We talk about it briefly and see how that goes. And the last but not least, that's probably the most important aspect, is the idea of content providers. And what were content providers? At least one person has an intuition, that's good. Yeah.
That was the different mechanisms you can hook up, for example, Mongo database, different storage systems.
Yeah, so basically this is nothing but an interface, like an API rather, that you need to implement yourself, right? But you get a fixed API that you can operate against from any sort of activity. And that's also one of the first elements that, or the first application component that's not an activity that you get to deal with in a way. Right, because we had activities which run generally in the foreground, do functionality, the business logic in a wider sense. We didn't talk about background tasks yet. And then we have 3 other components that had different functionality. One of them was the content provider. So the idea is to separate the provision of data and managing of data, persistent data, from you know, the use of it. So content providers are a mechanism to do that. Cool. Do we know any non-persistent way of dealing with data in Android yet, as of yet?
Class members.
Class members, the obvious one, yeah. But even if we go a bit more into the Android framework, so I should talk briefly about it. It's basically those bundles you are injected during instantiation of an activity, right? So if you have onCreate, you get past a bundle that you can use and that you can actually populate with values yourself. So here's just basically an excerpt of the context menu. So if you have creating a new activity and you want to store additional state, you can modify those bundles. And those bundles are basically, think about them like key value stores as well, similar to the shared preferences. Only difference is they die along with your activity eventually, right? So, so they will not be retained beyond that time. So that's one of the simplest way of dealing with this. But the more important ones are actually shared preferences. Again, I'll try to minimize the switching between my machine and the slide set because the stream will probably just die on me. But the idea is that shared preferences are roughly the same as those state bundles that you get, right? So you can access anything that's possibly stored there, generally by key, which would be a unique identifier, up to you. And then you obviously have the associated value of nearly arbitrary type. Generally, the shared preferences only allow you the object versions of the base types in Java, which is like you can have string values, integer values, double values, float, shorts, bytes, long. I think that's roughly it. So it should be 8 about there that you can access and manage there. So you have fairly simple forms of the fairly simple form of data that you can store there in a kind of a key value fashion, quite straightforward, not much magic involved. How do you actually use them? Oh, question first, for which kind of purposes would this setup be quite handy, shared preferences? For which kind of states management is it useful to use shared preferences?
These die between each activity.
Again, sorry, I didn't.
Did these die between each activity, as you mentioned?
This does not die. No.
Okay.
So the shared preferences don't die. The bundles die, right? So the shared preferences actually persist. The neat part is you use them, but you never care how it's actually stored. They will be attached to your activity and will be available beyond its lifetime, but you are abstracted from its physical representation. So that's good part. Looking at the structure of the data, we know it's key value pairs. What are they useful for? For storing what kind of information?
What kind of state your application was in. So next time you open it, you can go back to that state. Say, for example, you have an ebook or something, you can store what page you're on and how far down that page you are.
Yeah.
So next time you open it, you don't have to scroll back.
Yeah. What else? Yep.
Probably some general settings for application, like config.
Exactly. So that's the prototypical use for them, because you scary. You have a fixed set of data of values that you want to store. You don't plan to extend it massively or change it in any way, but you actually want to just keep the configuration data. For example, what's the date format you want to display in the application? What's the language you want to run the application in? Stuff like that, right? So things that are preferences generally that are known at design time. So that's the key use for shared preferences. The instantiation is quite easy. You can simply access them using get shared preferences or get preferences. The key difference here is that get shared preferences allow you actually to name your preferences. So you can have multiple sets of shared preferences for your application, if that makes sense. Whereas if you just call get preference, you only get one set of shared preferences that you can use across your entire activity. So that's the key idea there. That's the key thought. The signature is quite straightforward. You obviously have a, if you get shared preferences, you would have an identifier for the preferences, how you name them, I don't know, test prefs or whatever else. And then you have a mode, and that mode basically describes how they are accessible. By default, they should only be privately accessible to your application, not to other applications. Previously, it was possible to make them or share them actively, or it's actually still possible to, in theory, share them amongst or between different applications or activities, but it's not desirable. In fact, you should keep them private. So for sharing code, state across multiple activities, you're supposed to use different functionality when available. So that's the key idea. I think that's a bit of a example. You guys have dealt with this. You probably need to look it up yourself. Here's an example. So you get your shared preferences here, demo press in a private mode, and you want to modify them. In order to modify them, though, you need to get the access to the editor object that's attached to the shared preferences. So you just don't directly write into the preferences like using put and get.
So you need a separate instance for each activity.
It's the instance of what?
Of the shared preferences.
That's for each activity you have a separate instance of get. Yes, that's right.
Yeah.
They are attached to your application, right? And they're identifiable using this identifier. Or if you just call get preferences, you get you know, your set of shared preferences, but you can't further name them or identify them. So you just have a here in the left side prefs will now contain a key value set of key value pairs that you can modify and access. Right? Does it make sense? So the idea is there, you actually don't need to deal with any of the plumbing underneath it, right? So you just get it and it's magically kept by Android, right? It's managed for you. No big deal. The only thing you need to bear in mind, if you want to modify them, you actually need to use call edit on it, and you get an editor instance, which you can then use to to modify modify the actual shared preferences, put stuff in it, and afterwards, why do we need this possibly? Why do we need an explicit editor? Why can't we just get the shared preferences and write to them?
Race conditions?
Yep, cool. So that's the key idea, right? So you want some sort of transaction safety. So if one application is modifying, or one instance rather, is modifying the shared preferences, or multiple members, or perhaps even, you know, threads or asynchronous tasks, as they're called in Android, of a particular activity, meaning like secondary processes that are detached from the main thread. If they want to modify the preferences, then there is the risk of having race conditions, right? So we have conflicting access to particular properties. But if you use the editor instance, you basically modify the instance and then afterwards just call commit. You guys had databases, right? Everyone?
Yes.
Cool. Right. What's the since we're talking about it, what are the what's the concept called in the context of databases when we talk about commit?
Transactions?
Yes, right. Transaction safety, right? So there are a few properties attached to transaction safety, which are not that we need them here right now, but we'll come back to that later. Please, yeah. No? Yes? If nobody can answer it, I asked you for the 7 network layers. So it's just a deterrence here. Yeah, please.
Are you talking about like each transaction being atomic, and if one transaction isn't completed, you're
just give
to the state?
That's right. That's the concept of transaction safety. Yes, but there are 4 properties of a transaction that need to be retained by a database, relational database management system. Anyway.
Atomicity.
Yeah. And what are the 3 other ones?
Consistency.
Yeah. There was an acronym, right? No, no one.
I don't remember.
Okay, but that's good. Then talk about it. So, acid. Anyone? No, never heard about it.
Yeah.
Yeah. Atomicity, consistency. What's the I for? Sorry? That's the D at the end. What's the I before that?
Isolation.
That's right. So atomicity, either it works or it doesn't. The whole system is in consistent state before and after across multiple data modifications. Isolation, so if you have concurrent transactions going on, they shouldn't interfere each other, right? They need to be isolated from each other. And durability means it's persistent, right? So once the change is done, it should be, even if you lose power after a transaction, after the commit, the change should still be existing or not. If you lose power during, for example, a commit, during a transaction, then the C is more decisive. You need to have a consistent state. So you have a roll back to the previous state and everything is fine again, right? So those are the 4 properties. But you learned them somewhere, right? So you anyway. Okay, cool. Just to bear them in mind. We don't need them for now, but it has the similar properties here, right? It's about the similar idea of maintaining transaction safety. So share preferences, you played around with this. By the way, if you want to have insights on how to do any of those, apart from what I provide here, I try to be quite pragmatic and give you mostly the code directly because there's not much magic. the Android documentation is by far the best reference that's available. And it's actually written in a fairly readable manner. So I have a list of links at the end that I would suggest you to browse if you want to look at those particular characteristics. And it's quite accessible in that respect. So in addition to the share preferences, surprise, surprise, we obviously have access to the file system. So and it's actually quite straightforward. It uses by default the internal file system, so whatever memory comes with your phone. If your phone doesn't have an external SD card or any sort of storage, it doesn't matter, right? So then you still have an internal one. That's part of the requirements to have an Android compliant phone. And the key feature there is that you actually don't really need to deal with permissions per se. So you can just store files on your phone. It has a default directory. It's generally something like data, application, package, and so on. But it may vary per phone. So for example, if I ran it on Android 8 phone and so on, it spit out that value, for example. Yeah, I'm just wondering if I should. Well, I'll just show you the rough syntax how to get access to that. Just to bring that in. Do I need to increase the size? I suspect so. Well, it's somewhat legible, but the idea is that you can identify the folder that your data will be stored in for your particular activity by using from within an activity here by accessing the context that you have, right? So you get yeah, that was a bit redundant here, but you basically access the base context which is available in each activity, and then you can get the data dir, the files dir, so it separates the overall data dir from or the data directory from the higher level files directory that you can store information in. Yeah, so basically that's the way of how you would actually identify the location of your data that correspond to your individual app. So, but it strongly depends on the version functionally. So, and this data directory has subfolders that are for particular purposes. For cache, there may be image-related subfolders and so on. So you can browse through those ones and ensure that your data is properly allocated. The advantages of that approach is that you actually don't need to muck around with permissions too much, because by default every application has access to their own private data on the phone's internal memory. So you don't need to explicitly define permission sets, which is usually a pain, or can be a pain both from a developer's point of view, but worse from a usability point of view, because people are increasingly wary about applications that actually require access to memory, seemingly. But in fact, your application always has, but by default, private access. That's the key idea. So, cool. Yeah, so the, what I want to say here, right? Yes, so that's basically the idea. So you can basically write files and read files from there. We'll get into reading and writing in a second more. Some aspects that are specific are the idea of using notion of assets. So sometimes you have files, for example, in games that actually don't change, but you ship along with your program, right? So in the first case right now, if you get the absolute data dir, per se that's empty. If you start your app for the first time, you just have installed it on your machine, if you like. But you actually need to produce some content and store it there. But sometimes you want to actually ship data from the get-go. In this case, you would use the concept of assets that's built into Android as well. And that happens by default by actually creating an assets subfolder in your app project. Hang on. That's an angled mouse experience. Where are you? I saw you lately. There you go. Anyway, did anyone find my mouse? Ah, there you go. Right. So if you create a subfolder assets here, that would be the location that Android by default uses to access assets. So quite straightforward. It's literally a normal folder. And then you would be able to basically ship your assets along with your project. they would be retained there. It's quite straightforward. And then you can access them using so-called asset manager that by default will look into that very directory, simply a parallel directory associated with this. The downside with assets is that you need to directly access them using the asset manager, and it will just have a straightforward access to the files that sit there, but they are not indexed. For example, if you want to reference the files using the this R instance, right? So R and access the particular values, for example, or layout and so on. It won't actually show up there. The only way of doing this one is actually looking into resource directory and providing raw files in that particular subdirectory, in res raw, and then you are able to reference your resource from within Android applications using this R identifier. So we basically would say r.raw and then the file name that sits in that raw folder. So those are various ways of dealing with this. Is it visible? So yeah, that would be the default layout. So we basically would have some the asset subfolder there, and put some data in there, and then use. I'm not sure if that's visible. Yeah, somewhat, right? So the key thing here is that we have some sort of activity and we want to access the data that we're having. So you basically use an instance of what's called an asset manager. And this basically will just get a reference to this asset directory, and then you can open the asset file name based on the file name you actually provided, right? So, or that you stored in that set. Cool. So, and then you, this is plain straightforward Java I/O that you see here. So you open a file and get a reference to an input stream. You instantiate an input stream reader and then create a buffer that actually, or instantiate a buffer that reads the content of the file. And then based on some sort of characteristics, for example, you read the file line by line. Hang on, is it visible? Really get a laser pointer here, do I? There you go. So, so basically, here's the asset file name. You instantiate the stream reader, and then pipe this redirected into a buffered reader, and then you basically have some sort of entity that holds the abstracted strings. Let's assume it's a text file right now, and it consists of multi-line, strings simply, and to store it here right now we're using, for example, an array list of type string. So it's fairly similar to what we just saw in graphics, and you basically just add the individual items and use the determinant, the delimiter end line, right? So for the input line, and then afterwards you will have access to all the read items from in that array list, right? Simply to modify it. I don't know if it's a list of cities as in the previous example, or whatever else you actually want to deal with. So that's typical Java file layout. That's straightforward. It's compatible with conventional Java, so you can just use it, look it up and use it. So here more generally, a bit more enlarged, the focal aspect. So anytime you want to read a file, that's your way to go. So here, this takes an example of how to deal with files. Note the this one here. Java is, as you know, a platform-independent language, so runs on Linux, sometimes Mac, and certainly on Windows. And the different systems have obviously different line separator functionality, right? So, from one Unix-based system, we deal with new line, and in Windows we have carriage return new line special characters, right? So that embedded in strings. Yeah, please.
The stream can see that.
Ah, the stream can't see. Ah, you're very considerate. So let's see. Can the stream see that now? So those are the few aspects I just wrote down here. Cool. So we have them recorded. Promise now. Hope I get the camera pointed to the right place again. Cool. So we have different line endings basically for in different operating systems, and the way of dealing with this in Java, unlike in other language where you tend to hard code it, you use the system property line separator, because that will give you the operating system dependent special characters that are associated with the line end. Yeah, so that's why you see that here, end of line. Mouse again, cool. Yeah. So again, same pattern as before. We open the file, read it into buffered reader, and then do something to it. In this case, we're reading it while we have line endings, and then put it into the buffer with the operating system dependent line ending and so on. And then we can consume the buffer and do something to it. So that's all the functionality that you basically need. So you have the file available. Similarly, writing, that's quite straightforward. So if you, for example, have output you want to write that sits in a string S, you have a file output stream that you attach to the file that you want to write to. Again, the mode in which you want to write is this important. By default, it should be private. In fact, all other cases are deprecated. If you actually use the Android Studio IDE anyway, you'll see that deprecated functionality in Java or Android is indicated by having a strike through the actual function, so or constant or whatever else. So you're not supposed to use it, but you can still use it. So generally, Java and therefore Android, they are not really harsh on deprecating functionality hard, meaning they're not necessarily removing it, but they're marking it as deprecated. So you're discouraged from using it. And then it's writing it to the file output, and from that stage onwards, it should be in your file. So that's the principal ideas. There are any particular questions there? Because that's not something I want to go deep into, because that's very much Java functionality, not so much Android. I want to stay at the high-level conceptual bits that are different from Java, different between Java and Android specific.
Yeah, I'm surprised. Isn't there some sort of Android file manager class?
Not per se, because it depends really on the type of data you're dealing with, right? So that's an example for text files. If you're dealing with some sort of other different encoding, you need to use a bit different buffer to actually write it. So, but it's, yeah. So, but the point is this: fundamentally, think about all those I/O level operations as fundamentally Java operations. So whether you actually look for a Java tutorial or an Android one, it's fairly close. That said, there are some exceptions here and there. For example, how to get references to your location and so on. But it's more in the API than in the actual functionality. That's the difference. Cool. External file system. So if your phone has an SD card or doesn't have an SD card but a built-in SD card or something like that, I'm not sure what's the current trend in phones. Do we have removable SD cards again or not?
It's common in a bunch of Android phones, but some ship without them.
Yeah.
But usually those have a decent chunk of internal storage in return, I guess.
That's right. So yeah, it's a bit of a mixed bag, and we'll see. I mean, that's one of the elements of the Android fragmentation, that the market is not really clear about what should be expected from a phone. So you can't actually expect that a phone has a SD card reader, let alone an actual SD card in it. So of course. So the key difference here is in comparison to the internal file reading file system is that you actually need to test carefully whether you can actually access the files before you do it, right? So whether your SD card is actually mounted. That's one of the key challenges there. The other thing is also that you need to have certain permissions to actually do that. So again, for the internal case, you don't need to do anything particular. Please.
Android also has a hybrid storage system so that it can use the external storage as internal storage, but that is also phone dependent.
Right. Phone dependence is ugly. Yes. I know that you can indicate the preferences for installation of apps on either external or internal. I think, yeah, here from Android 8. Okay. So the point is, I think you wouldn't need to be worried fundamentally, because in worst case you always write to internal. So I don't know about this hybrid layer, but I would expect then it would by default you would write to internal, and
Probably.
if possibly write to external, right?
Yeah, I haven't actually tried developing for it.
Okay.
I just know it exists.
Cool, that's worthwhile. If you find anything more post an issue or something like that, then we can explore that as well.
Yeah.
So see if that's interesting. So key thing, yeah, check for mounting. In terms of API, if you want to check what's the actual the directory, storage directory on your phone, that's the function call up there, right? So you say environment.get external storage directory, and if you want to have the private files that are associated with your application, so a subfolder in the overall SD card, then you can actually use get an external files directory. So be very mindful when you're dealing with this. There's not a single function call, but it's actually quite a set of available directories that you can have. For example, you have the data directory, external, that's the state, we get to that in a second, external storage directory, then the external storage public directory, a particular one, download cache directory, root directories. So be very mindful of what you're actually looking for. But generally you want to look into your data directory that's associated with your particular application. So in addition to, that's down here, right? So that snippet there. In addition to actually thinking about where's my directory and where my files actually reside, and you can then access them using the read and write functionality I just showed you, we also have, we need to do the check about with respect to the external storage state. So in this case, every time you want to access your medium, you want to check first whether actually the medium is mounted, removed, unmounted. There's also a ejected bed removal. So for example, if your card has been removed without properly being dismounted first and things like that. So you can check for all different states of your SD card as well. So bear that in mind when you, or it's not formatted, for example. So if you have a blank SD card in there. So it's important to get that right. Generally, the environment class is full of constants that are not only related to media and file access and so on, but across the entire application development framework. Most of the relevant constants are managed in the environment class. So it's worthwhile keeping an eye on that one. You will encounter it in different contexts. Another one, so two important ones of functionality, baseline functionality that you want to look at is context generally, because it describes your application specific context. So for example, if you go base context, it gives you all the functionality that's available from within your activity, right? So, and we get to back to some of them later on. You can list the databases attached to it, delete them, delete files that are associated with this in your private storage by default, and list the associate files, the assets, and so on. So context is always a good one to have handy if you're not sure how to proceed, to see if you find the functionality you need in there. So let's see. Yeah, cool. That still works. Cool. Anything else I wanted to say? Not much magic there. Again, since Android 8, you can indicate the preferences. By default, it was always installed in the internal, unless you set it on the operating system level, would be installed in the internal storage of the phone. But now you can set it application dependent in your manifest that you actually prefer the installation on the external card wherever possible. And the alternative is auto, which is bound to the operating system preference that will basically pick the preference that's selected in Android on your phone, basically. Cool. Good. Permissions, so that's the key difference here. In the internal storage case, we actually didn't need to deal with permissions, right? So we just write to it and read from it, we're all happy, but only manage private files there. Here, unfortunately, you actually need to modify your manifest and indicate the permissions that you want to give. For example, reading from external storage or writing. Writing implies reading in Android, so if you get the write position, you don't need to give the read permissions. So yeah, basically that's one of the things you need to be mindful of. I'm just pointing to the developer resources by Android itself because it's super straightforward just to have a look at this. Some static charging going on here. All right, good. So hang on, where am I? Yeah, okay, let's briefly look at this before. So I just want to, one other aspect to look at is SQLite. As I mentioned before, as Marj in fact mentioned in the very first lecture, is that the application framework in Android has a built-in SQL functionality that's exposed to all activities. So it's available to all the higher level development functionality. I'll just bring up that architectural overview again. probably quite handy to have. Bear with me. It's a random page right now. I didn't really cut that up properly. So again, notice that we have the different functionality levels that are provided, right? So we have the Android core runtime on the lower right there, Delvik and the newer Android compilation engine, and then we have libraries, and one of those ones is SQLite, and this is basically available to any app or activity that you're dealing with on the higher level. That's precisely what we are talking about now. So I'll probably leave that slide there because we come back to it in at some later stage. But how does that fundamentally work? Well, the key call that you actually do is to simply call open or create database. SQLite is very lightweight, so it's not super expensive to create a new database. It doesn't require you to deal with permissions, so it's permissionless, but this also implies that the database is supposed to be used privately as well. So it's not to be exposed to other activities or applications. For this purpose, we use the content provider, as we'll briefly see later on. And it's quite straightforward. You call open or create database from within your activity, get a reference to a database with the name of your choice. So if it doesn't exist, it's created, else it's referenced again. And well, then you can create SQL queries and simply run them against your database if you like. In this case, creating tables. We're obviously not going deep into SQL because you guys know all that one. Quite straightforward. So there are different types of queries that you can, methods you can run, please.
What are blobs?
Oh, what are blobs? Anyone?
Type of data.
Yeah, there was some.
Binary large objects.
Exactly, binary large. Yeah. So yeah, what's an example for that?
Image first.
Yeah. Right. So yeah, images, for example. I mean, it's really about managing size mostly. Yeah.
And this is stored on the phone's internal storage?
That is on the phone's internal storage by default. I'm wondering whether if you install it externally, I would need to check that. I'm not sure if you install the applications externally, if you can actually also store the database externally. But by default, it's on the internal storage. Cool. So apart from the exec SQL query, which basically doesn't return data in particularly, so you can assess success, but this is the only thing it actually does. There are more preferable methods that you should use on your database, such as update, which are actually is meant to obviously update data, or insert to actually insert data into your database as well. We get to that syntax bit in a second. It's quite a bit different, so you're actually not passing fully fledged SQL into it. Any intuitions as to why? For data manipulation generally, why don't we use SQL statements? Would be very convenient. In fact, you can. I mean, I'm not saying it's impossible. You can use the exec SQL as mentioned before, but preferably use those this API, insert and update. Anyone?
One less thing that could go wrong. You don't have to maintain the SQL code.
Yeah, true.
You know
yeah.
that it's correct.
That's right. Yeah, cool. So the underlying SQL is generated from that method. Therefore, you don't have to care about it. It will be syntactically correct. That's cool. Yep. What else?
It's kind of independent of what's lying beneath, so separated.
Yeah. Cool.
So queries can change internally how database is built.
That's right.
But
So
then you have the same access to the interface.
Yeah.
Kind of.
So you're right. I mean, in principle, you're right. A database management engine syntax could change, right? For interacting with this, you don't need to deal with an API level. That's pretty good. Yeah.
You have prepare statements
That's And why do we use prepare statements?
to avoid, for instance, SQL injection.
Exactly, right? So that's the key to get at. So we don't need to, we're actually removing some of the security challenges out of the box by using de facto prepared statements, because they're basically converted into prepared statements and then executed on the engine itself. Slightly different from the way how Java does prepared statements. They also work on Android, but don't use them, use this functionality. It's slightly different in its use case. But the idea is there that we never assemble strings or particularly the SQL queries ourselves, but actually have them automatically assembled and then sanitized on that process as well. So actually checking for nested SQL statements and stuff like that. So it's for example that one of the parameters is not just starting with a semicolon and then says drop table table name and semicolon, actually drops your table in the process of executing your query. That makes sense? So you, for example, if you hard code a query, you could have, and you're attaching or you're binding an input value, an external input value to it. This input value, if it's a string, could be an SQL statement in itself, and it could just forego the preceding SQL statement. That's not happening. And basically, inject a command such as drop database, drop table. So it basically drops your table, or if not, delete the entire database from within the user input. So that's part of the reason here. Cool. The other aspect to talk about is transaction safety. Implemented in SQL or in Android, it's done this way. You basically just say begin transaction, do whatever you need to do, meaning all the creates, inserts, updates, deletes in your database. And the only thing you need to do is to set the transaction as successful. If you don't do that, it implies that the transaction has failed. And if you end your transaction, it would do a rollback as opposed to commit. Yeah, cool. No magic. Okay, you guys probably need a break, I think. Or had needed a break already half an hour ago.
The end transaction is commit.
Sorry?
Was that what you said? That the end transaction is equal to a commit?
Right. Now what I want to get at, just following up on our previous transaction talk. So you have a begin transaction statement, right? Begin, then you do all your stuff you need to do, all the SQL updates, deletes, inserts, and so on. And then at some stage you need to decide whether this transaction is successful, meaning if I reach up to that point here, most likely before ending the transaction, you set the transaction as successful, right? You say, okay, if you reached here in your procedural execution, then it's I can consider this transaction to be successful and followed by an end transaction. If you don't set this one here, then it would imply that the transaction failed and it will be rolled back. Does that answer your question or not at all?
I was just confused when you jumped. I didn't get which one you pointed at.
The second one from the bottom.
The middle one?
Yeah, the middle one.
Yeah.
If that works for you. Okay, cool. All right. So, good. Clarified somewhat? Easy, right? I mean, that's it's just
So
syntax.
End transaction actually commits the thing if you previously had set transaction as successful.
Yeah, that's
but
right.
If you didn't, it will roll back.
That's
So
correct.
it will do different things depending on what happened between the two start and end.
Yes, but only dependent on the middle statement. Yes. So if you forget to set that and you realize, oh, nothing is happening ever to my data, and most likely you just forgot to set a transaction as successful. That's it. Just one call. It doesn't have any return. It's just a flag that's basically set internally. So yeah. So it's the only thing to bear in mind. Cool. Let's do 10 minutes break. So 1:15 we continue. The balance of you anyway, the ones that survive. And then we get into a bit more SQL, and before we look into ORM and content providers.